this particular example, we're going to look at how to simplify what we're calling a complex fraction. When we're talking about a complex fraction, we're talking about a fraction that either in its numerator or its denominator contains more fractions. So I have fractions within fractions, which makes it look rather complicated or complex. With that, it's kind of where we coined the term there. So in this complex fraction, the first thing that I need to do, and I tried to color code this, I made the big division bar here between this, separating my numerator and denominator different colors so we could see that a little bit, is we need to simplify what's up here in the numerator into a single fraction as much as we can. And then we need to do the same thing in the bottom. We actually need to do this subtraction to simplify this into a single fraction. And then we'll be ready to divide fractions. So it's kind of like a review of a lot of things we've done in other videos. We need to simplify this numerator by adding these two rational expressions together. We need to simplify this denominator by subtracting these two rational expressions. And then finally, we'll need to simplify that by dividing whatever rational expression's up here by whatever rational expression is down here, which actually turns into a multiplication problem. So it's a very good review of everything that we've done, going back to adding, subtracting, multiplying, and dividing some rational expressions. So let's go ahead and try to do that now. And it's going to be hard for me to fit all of this on the board, so I'll probably have to go back and erase since I have this small whiteboard as we work through the problem. But let's go ahead and try to get common denominators within our numerator so that we can put these together as a single fraction. I see this one has a factor of x in its denominator, this one has a factor of x plus 1. So to get common denominators, this fraction is going to need to get multiplied by x in both the numerator and denominator. And this fraction is going to need to get multiplied by x plus 1 in both the numerator and denominator. I'll go ahead and do that now. To simplify that, I'll go ahead and multiply this out over here. That would give me x squared minus 2x plus x minus 2, and then plus this 2x here, since I can write that all as one fraction now that they have common denominators, and that common denominator is x and x plus 1. I'm not going to go ahead and actually multiply out that denominator because ultimately I want it to be in its factored form to maybe simplify some stuff later. We'll clean that up here in a moment. Get this other marker out of the tray. Let's go ahead and put this together in the denominator as well for that. So we don't have common denominators down here in this denominator either. We have an x minus 1 here and we have an x plus 1 there. Those are different factors. I know they look very similar. You can't just do something to change a sign. It doesn't work that way. They're different factors. So this fraction will need to get multiplied by the x plus 1 on the top and bottom. And this fraction will need to get multiplied by the x minus 1 on top and bottom. At that point, they now both have x plus 1 and x minus 1 in their denominator. Let's go ahead and do the distributing and simplify a little bit here. So that would give me 3x plus 3, and then make sure you take the negative with this 1 that we're distributing. That would be negative x plus 1. The negative 1 times a negative 1 makes positive 1. And that's all over the denominator of x plus 1, x minus 1 with that. So now I'm going to go ahead and jump back over here into this space. I'm going to try to clean up the numerator of my numerator and my numerator of my denominator. That sounds rather confusing to say. I have some like terms I can combine up there. This minus 2x and this plus 2x are going to cancel one another out. So that should come down to be x squared plus x minus 2 all over x times x plus 1. And then my big fraction bar. And cleaning this up down here on the bottom, I have, let's see, I have 3x minus x, which makes 2x. And then I have a plus 3 and a plus 1, which makes plus 4, all over x plus 1, x minus 1. Still looks rather complicated, a little bit messy. I have some factoring I can do still, so I can actually factor this numerator a bit here, and I can factor this numerator a bit here. So I'm going to go ahead and do that next. Factoring the numerator here, I would have, let's see, x plus 2 times x minus 1. I needed two numbers that multiplied to negative 2 and added up to positive 1. All that was over x times x plus 1. And then I have my division bar, and in my denominator, the numerator of said denominator actually has a common factor of 2, so I can factor out the 2, and that would leave me with x plus 2, all divided by x plus 1, x minus 1. And I'm almost there. I'm going to go ahead and erase this top part so I have some more room to write on this small board. We just did that. So this is where I'm currently at. And finally, I have one fraction divided by another fraction. So when I do that, instead of taking this fraction divided by this fraction, I'm going to take this fraction and multiply by the reciprocal of that fraction that's in the denominator. So that would give me x plus 2 times x minus 1 over x times x plus 1. And instead of divided by, I'm going to go ahead and change that now. Again, I'll still use the red to represent that operation between them. That now is being changed to multiplication, and I'm going to be multiplying by the reciprocal of this fraction down here. So the x plus 1 and the x minus 1 would now be in the numerator, and the 2 and the x plus 2 would now be in the denominator. At this point, since it's multiplication, I just multiply straight across, so this might as well just all be one fraction like that. And now I can start trying to cancel some common factors that I see in the numerator and the denominator of this whole thing. Here I see an x plus 2 in the numerator. That x plus 2 can take out that x plus 2 from the denominator. Let's see. Here I see an x plus 1 and an x plus 1 that can cancel out there. And that looks like all the common factors that I can cancel out of both the numerator and the denominator, leaving me with x minus 1 times another x minus 1. I could write it twice, or I could actually just do this and write it as x minus 1, that quantity squared, in the numerator. And it looks like in the denominator I'm just left with an x and a 2, which would be 2x. So this should be our simplified form of that complex fraction. This problem didn't ask me to make any statements about restrictions on the variables, but if it did, I would just have to go back and look and be careful and make sure that I excluded any values of x that would have made a 0 in the denominator of any of the fractions that were involved at any point in time. So that's how you do that. Hopefully you're able to follow. It was quite a bit of work, and you can't see it all on the board here in the end, but just pause the video where you need more time to digest.